All right, students, we have already learned about how to determine the protons, electrons, and neutrons. Ape man, ape, the atomic number is equal to the protons, which is equal to the electrons. Okay, and then man, this was ape. For man, the mass number is equal to the atomic number plus the protons. Or you could say mass number is mass number minus the atomic number equals your neutrons. However you want to do it, it all works out the same. What we've learned about electrons and their energy levels so far is that there is a maximum number of electrons that can be in each energy level. There is a maximum number of electrons that can be in each energy level. For our purposes here in junior high, we're only going to worry about the first 4 levels, and those maximum numbers, you can have 2 electrons in the first level, 8 in the second level, 18, 32. This is a big review for you, or should be. All right, that's a lot of information, but there's still a little bit more to add. In order to make the stuff around us, atoms cannot be lazy and just sit around. No, they have to find other atoms they want to bond with. Atoms only bond by using the electrons in the outermost energy level, and those electrons are called valence electrons. These are the electrons in only the outer energy level. Hold it. Before we go on to this, let's just talk about this real quickly. Let's pretend that we have an atom of boron. I'm going to flip this over for you. You have an atom of boron. Boron has an atomic number of 5, and most boron atoms have a mass of 9. I know that because I looked at the periodic table. With this information, and this is what we've been working on the past 2 weeks, we know there are 5 positive protons in the nucleus, and sorry, this should be 11, and 6 neutrons in the nucleus. And then our electron arrangement, because our protons and neutrons are the same, would be 2 in the first level, because it maxes out with 2, and then the remaining 3 in the second level, for a total of 2 plus 3 is 5. This particular atom would have 3 valence electrons because it has 3 electrons in its outer energy level. When we get a little bit further into chemistry, we're going to learn that this electron total, the total number of electrons, will not always match the total number of protons. Okay, but for now, you need to know that the valence electrons are those in the outermost level. All right, going back here, introduction to the periodic table. Before we can go any further, we must pause and get a basic look at the periodic table. Although many men in the scientific community contributed to the development of the periodic table, Dmitri Mendeleev is thought to be the father of the modern periodic table. He wrote down all 63 known elements at the time in the 1860s and arranged the cards in a table in order of ascending, which means smallest to biggest, atomic number, grouping elements of similar properties together in a manner similar to his favorite solitaire card game. It was published in 1869 and has become the standard for how scientists classify and utilize elements of the periodic table. Since 1869, we have added 29 more elements to the table following Mendeleev's arrangement by atomic number for a total of 92 naturally occurring elements. Periodic table basics. The PT consists of metals, nonmetals, and metalloids. If you look closely at the periodic table, you will notice a dark line toward the right-hand side of the table in the shape of stairs. This line is known as a zigzag line. Yes, I know it's a very scientific term, but we're always going to call it the zigzag line. It separates metals from non-metals, and along the zigzag line are a few elements called metalloids. In the middle of the periodic table are what we call transition elements. They have different rules for everything, so we are not really going to focus on those too much. Characteristics of metals. There we go. Metals are going to be shiny. Okay, that means that they have luster. They are good conductors of heat and of electricity. They are malleable, which means they can be hammered into thin sheets, like think of aluminum foil. And they are ductile, meaning they can be drawn into thin wires. Think of a copper wire. Nonmetals are exactly opposite. They are brittle, which means they break easily, dull in color. They are poor conductors of heat and electricity. And there are a lot less of them on the periodic table than there are metals. Finally, the metalloids contain properties of both metals and nonmetals. All right, the metalloids are going to be those that are found along the stair-step line on the periodic table, with the exception of aluminum. So all elements touching the stair-step line except aluminum. And some of the special elements we need to know, aluminum. Some of the special elements we need to know are certain groups. We need to know that the first column 1, which is also known as group 1, these are called alkali metals. Group 2, alkaline earth metals. Group 17, these are the halogens. And group 18, these are the noble gases. There are more special elements we're going to look at, but right now we'll stick with these. We do want to say, though, in column 1, group 1, they are all metals except hydrogen. We'll talk more later as to why hydrogen is not one of the alkali metals. Okay, now moving on from here, you need to look over all the notes that you picked up in class. You're supposed to finish the activities. Let me look here. You're supposed to finish these notes, and if you did not get page 50, the IONS worksheet completed, then you need to have that done before next class. All right, I'll talk to you later. See you in class.